we now have our next talk, which is Amran talking about digital health.
Yeah, hacking in healthcare.
Hacking in health. So yes. So go ahead, Amran. And Jan.
Welcome. Due to some time constraints and personal circumstance, I've not been able to prepare this talk for as much as I'd like. Also, I'm completely and utterly tired, so I won't be giving the full talk. My compatriot, companion, colleague, call him what you will, Mr. Jan, he will be doing the rest of the talk. But I'm going to give you a quick 5-minute redux of what my talk was about, which essentially starts out by saying that everything you kind of see in terms of digital services and apps and little things that you stick to your wrist, they're all a bit kind of dodgy, if not useless. Your body is a function of hundreds of thousands of years of evolution. It works on timescales of months and years rather than days and weeks. The most important thing you can do for your body in terms of monitoring is actually not to monitor yourself and eat well and eat healthily. The whole 5-day thing of fruit and vegetable comes from a Californian study suggesting that if you eat 400 grams of fruits and vegetables a day, you will be healthier. However, most dietary research is less causation and more correlation. The whole thing with wine in France and a whole bunch of other stuff, it's very much kind of, oh, well, these people seem to be doing this and we think that's healthy. One of the things that kind of sticks if you read through research papers is the Mediterranean diet, and researchers go bananas over that. There aren't too many people doing kind of causation studies at the moment because it's slightly dodgy. You basically have to put a human being in a room for a couple of months and feed them exact amounts of food to kind of, figure out what effect it has on the body. Funnily enough, there's an institute in America set up recently by a philanthropist, and they're actually starting to do this, so there should be some interesting research coming out over the next couple of years about it. But essentially, what we know is not really what we know, and if you're taking vitamin pills and silly diets, well, you're probably harming your body as much as you're doing good. Stick to a diet that's more vegetables than meat, eat sensibly, eat variably. Some things that are good for you will also be bad for you. Some things that are bad for you will actually be good for you. They've discovered things like with diabetes, certain things that you eat that are bad for you actually produce a response in your muscles that kind of help with insulin, dealing with insulin, so you're not affected by things like type 2 diabetes as much. The second part is if you are going to monitor yourself, the kind of basic things you want to monitor are things like blood pressure. Don't buy the little cheap ones from China that fit around your wrist. Buy kind of a decent one for about 50 quid. It won't be accurate, but it'll be accurate enough. And what you want to see, what you want to look for is trends over time, over 6 months or a year. Another good thing, in fact, an essential thing I would suggest if you want to monitor yourself, you can buy these strips in the tub, and they're urine test strips. And they turn all different kinds of shades of brown and yellow, and they indicate what kind of things that might be wrong with your body. And they generally catch a lot of long-term disease, things like type 2 diabetes, kidney failure, and a bunch of other stuff. And they're really good first indicators. If your body is in serious trouble, you need to go to a doctor. You need to seek out that technical science. If you're fairly healthy, maybe there's something in your diet. And I kind of encourage going to people who aren't quite doctors, but aren't quite nut jobs. Some herbalists are studied for 2 years in this kind of stuff, and they're actually worth going to because they will look at your whole holistic way of being and kind of try and see any patterns in that. What else? Yeah, I think that's kind of it. Don't buy into the whole kind of monitoring your heartbeat every other bloody second, or buying a little EEG device. If you've got a specific complaint and your doctor's worried about you, they'll do that anyway, and doing it more often at home can help, but usually not so much. So thank you for that. Now I'm going to introduce you to Jan, and he's going to carry on the talk in a slightly different direction. Thank you, and I'm very sorry I couldn't give you the full one.
Am I on? So hi, I'm Jan, not Amran. That's Amran. I can do this. Am I audible? Okay, good. I was kind of suckered into doing this talk, and I've done it before at other hacker camps. and he told me he was feeling not so well, and asked me to fill in the rest of the, what is it, half an hour?
Yeah, you got about 20 minutes left.
20 minutes, awesome. And what I want to talk about is building houses. Completely different subject, so if you want to walk out, fine. Now would be a good time. If you want to stay, awesome. A couple of months back, we were discussing things that came out of a bit of a hobby of mine. I had built a CNC router, which is like a 3D printer, but it takes away material instead of adding material. So you could do wood and aluminium and that kind of stuff. And as soon as you build one of these machines, you start looking for nails to hit with it. Because you've now got a very fancy hammer. You're very proud of this hammer. Where are the nails? What do you do with it? You know, the guys at the laser cutter tent, they build all these little machines and little gadgets with the laser cutter because they build, you know, a very complicated light-giving hammer. And that got us thinking about what we can do with it. Yeah. We'll do on-the-fly slides because I didn't bring mine. It's a very nice hammer equals CNC sign. So what happens is you're looking for things to do with this machine. And normally you just pick a job and find the tools that, you know, go with it. And we just had a tool and we're clueless about what to do with it. That kind of led us to building, no, that's not true. Someone showed us an episode of, what's it called?
Grand Design.
Grand Design. It's a BBC show, you might have seen it. They take these old weird houses or like a water tower or train shed or something and they build someone's awesome.
What was the website that did it?
Sorry, what?
What was the website that the company?
Facet Homes. Don't mind that. So what happens is they built this house out of plywood, and it looks amazing. And what they did, what they actually did differently than any other building companies, they bring a shipping container with a CNC machine in the shipping container to the site that they want to build at. And they just shove in these sheets of plywood, you know, the regular ones that you use for you get at the building depot. And from these sheets of plywood, they cut all kinds of shapes, and they stick them together with nails and this pneumatic hammer thing. And from these things, they build boxes. These boxes go on the floor, and they comprise all the walls, and they make the ceiling out of them. And these things actually turn into a really awesome, cool house. Do you have anything online? No. Why not?
I don't know which one it is.
The internet's broken. Is it?
Amran's broken.
Amran's broken. We knew that.
Which one is it?
Facet.
I don't know what you do.
What are you doing? Sorry.
I'll carry on, shall I?
Yeah, you can.
So, using this construction method, they basically pin a bunch of metal spikes into the ground, lay down wood planks, and then attach the boxes onto the wood. So they'll make a floor out of these cuboidal boxes, and then the walls, and then the ceiling, and then walls, and then the roof.
It's not really visible, is it?
Let me try and fix it.
You try and fiddle with the browser thing. So what they do is they design the whole house in your regular AutoCAD or something, and they design every single one of these boxes, which is, you know, nice, awesome. They can build every shape they want. They build tree house-like things. They build mansions. They build this little thing, and this obviously takes them a lot of time to get from, you know, someone's plan, someone's design in their head, and then doing the whole architectural thing, designing the whole house off-site in a 3D program, and then once they've done all this, they go on-site, hopefully in summer, and they just mill or print the whole thing in 2 or 3 weeks. And if they find something that, you know, they overlooked, they change the design, do another piece of plywood in the machine, and then out comes the piece they need. I'm a programmer, and I like to do, you know, logical things, and I like to do things that I can reproduce.
He's boring.
So that's why the whole that's why the whole CNC machine kind of, you know, intrigued me. I can make a computer do what I want in the physical world, and seeing that episode of Grand Designs, I thought, what are they doing? Why are they deliberately trying to make, add hours into this project. They're just designing this thing for months and months on end, and then the client comes in as it's gone winter now. I'd like thicker walls, or I need more overhang on the ceilings. I don't know, whatever. They just keep changing the models and keep changing whatever they want because they're getting time to do this. That kind of boiled down to why aren't we doing this in software? It's not a really difficult problem. It's a problem that has a lot of what are you doing? A lot of steps involved, but it's not difficult. There's no rocket science involved, and that made us think about what you really want to do. Is you want to have something like a browser where you can go in on your iPad or your work computer while you work. Your boss doesn't know about this. You go online and you kind of just draw the outline of your house. You draw what you probably can afford and want to use as a house. You draw your living room, you draw your sleeping bedroom things and bathroom. And on that map, you take the time to actually mark down where you want to have power sockets and water and windows and all that kind of stuff. You can do all that stuff in a browser nowadays. Browsers are amazing. They 3 years from now, by the time we get to actually building a house, they'll be even better. And you just draw the building plan like you do in Sims or Theme Hospital. Maybe you're familiar with these games. And once you've done that, and at some point in your life you'll actually be able to buy and afford a plot of land to build on, that's the moment you want to have some speed in the project. You don't want to have the piece of land sitting there for 2.5 years while some architect does all this architecture things, and I don't know, they might do really fancy things, I don't know. I've never talked to an architect before. But what you really want is to have the house the next month, because you don't want to have money going to your old house and money going to your new site, and that being some muddy pool where you can't live. So we think it's possible to actually make a building plan out of this floor plan and slice it up into wall segments like these. So we just kind of think, oh, that's a wall 3 meters wide. We need that many boxes. That's a wall that many meters wide. We need that many boxes. This is a box with a hole on this place for the electrical sockets or the water mains or whatever. You can all do this in software, and from there on, you just get all these box designs and shove that onto the next program, which will actually render the box, or render all the stuff that needs to be cut by the CNC machine. There's not really a point to this, except for the fact that if you do this in software, you can just tinker on it, you can work on it, you can build it on scale models, and then by the time you actually get to building a house, you probably have running software that you can use to actually build it. Hopefully you've been sharing this on GitHub or some other program or software, and people can actually help you add features to the house. So I'm guessing you can start out with having a shed-like structure, 90-degree angles, not too many weird windows and that kind of stuff. But if time advances and more people add and join and start building code for this, it shouldn't be too difficult to add like roofs like this, or flat roofs, or suspension, or I don't know, cantilever things.
Yeah. What Jan is not explicitly saying is that picture there, every line was hand drawn, and what we're saying is you can automate that and you can get a piece of software to draw it for you.
Pretty much.
So we think this could kind of transform middle class, low income housing quite exceptionally. It would put the means of construction essentially in the hands of people rather than architects. I mean, you still have to abide by the laws and regulations, but you can build that into the software to make sure things meet those standards. And the architect just becomes a checkbox. It's like, does the architect okay the plan? Yes, go ahead, build it. And I think the beauty of it is you can build I mean, they've already built houses like this, and they've had about 5 people build the whole house. You can also work in technology into this, so you can fill the gaps with insulation. You can work in underground heating. If you buy standard size glass panels for windows, you can also work in extra insulation that way. You can also include implicit design features which are meant for human beings, because if you buy a modern house right now, you might have like a little plug in the wall for your internet, but they don't put a power socket there. They put a power socket like in one end of the living room. It's like, what's the point? You're doing it on cost purposes, and you're doing it for your own convenience. You're not doing it for the convenience of the person buying the house. So it doesn't just end with little sockets. It goes right down to things like bathroom, placement of rooms, layout of the house. It can be customized quite a lot in the beginning and produce a plan for a house which you can build with you and your friends, pretty much.
Yep. Yeah, while we were thinking about what you can do as soon as you actually remove steps from your hands and give them to the computer, that gives you a bunch of opportunities that, you know, they're not really obvious at the front, but once you think about them, for example, why does everyone always rent some dude to do their kitchen or rent some dude to do the tiles in the bathroom? Because we don't do that very often. We do that once, and then you need to live in that bathroom for 10 years, so you see every tile that's slightly off. So that's why you pay some bloke who doesn't even properly speak English, like me, a whole bunch of money, and they tile the whole room, and yay, it's all straight-ish. And if you do this, if you design the house on a computer, and if you actually have a computer cutter, like a router, cut out the actual wall panels in your bathroom, you could easily ask the computer to just mill out square pieces where the tiles should fit. Just tell the computer how big the tiles are, what kind of configuration you like. You can do this in software. You can work on this for weeks, because that's what we're good at. You can do this on the couch. Bring the code, make the code, share the code, whatever. And then by the time you actually get to building a bathroom, you just buy the tiles. And then the computer will make all these nice little boxes where you can put your tiles in. It'll be straight. Same goes for underfloor heating. You can just ask the computer to just make these little, well, what's it called?
Things that you put things in.
Little ditches in your ground so you can lay the underfloor heating in. Question?
Hang on.
Testing? Yeah. Do you think the future will be going this way, or will it be using 3D printers to print the houses?
So the thing with 3D printers is what they don't tell you is they're like really, really, really precision machines. They're like 0.01 precision. And to have that kind of precision, the level that the machine sits on needs to be perfectly level and perfectly flat in all planes, in all directions, right? And it needs to be dust-free, because if you have a bit of dust and it's printing a house in 3D, wherever the bit of dust is, it slightly raises the gantry. So you have this little notch all the way up the side of your house. But not only that, you've got to level out all the ground around where you want to build to be perfectly flat. And it's like, that's completely useless. You're going to spend like tens of thousands of euros or pounds or whatever currency you use here to completely level out a bit of area so you can 3D print it. And for that money, we reckon we can build a 2-bedroom house for this in about 30,000 euros, which is not silly money. It's not insane money. Young people can afford it. That's how much it would cost just to level out the ground, just to build 3D printing for 3 houses. They don't work in disaster areas because you can't even build a cardboard house in disaster areas without like trouble. How are you going to get a machine that requires tolerance of like 0.1 millimeters?
There's a chap, I'm just reading this last week or so, chap, I think in this country, that has built used a converted 3D printer, well, I guess he built it himself, to do a castle-like summer house in his back garden. And I mean, it's not a castle, it's a summer house, but it looks like a castle. And I think the only real problem he mentioned was having to mix up the cement himself to get that accurate. I've never tried 3D printing myself, so...
Well, designing these machines that go X, Y, and Z, all the 3 axes, means that the machine needs to be absolutely 100% rigid. And the bigger that machine gets, the bigger the problems get with just general engineering. Building a bigger CNC is a pretty big problem, but the CNC only needs to be as big as the biggest box, which is, 100 times smaller than the actual size of your house. And the machine can be in an enclosed area. It can be in a shipping container, whereas your 3D printer needs to be out in the wind and the rain and all that kind of stuff. And even then, if you're going to pump up all the concrete to the second floor, that means you have this huge load of weight shifting all the way up, and your machine needs to be capable of actually holding all that weight up and not bending and not, twisting. Because, like you said, it'd be weird if your top half of the building is just slightly off. Doesn't look right.
So if I'm understanding correctly, you're saying that you can use this technique to build affordable homes.
Yep.
So for a complete home, how much do you think that would cost in euros?
I know the facet guys. There's a construction company in the UK that actually does this, and they spend, I think, half of the money on, drawing the CAD things and doing all the work in advance that the software could do. They make amazing buildings because they spend all this time on it. But
so if you build a building with this technique, what sort of budget could you build a complete house for?
We did the costing on the plywood and some of the other costs, and we think it's around 30,000 euros for a very small 2-bedroom house.
So £30,000 to buy a complete house?
Yeah.
So when's that going to be in Kickstarter?
No, so this project is also taking the viewpoint of like the open philosophy. So our designs will be open, our documentation will be open. We kind of expect people to take it. The problem is you need a lot of expertise to get involved with the project to do it, and that's a barrier to entry, sure, but it's not a barrier to entry to use it. So maybe small companies pop up that use it and kind of start spreading it around. We're doing it as a thing of passion. It's a private project for us. We're not looking for funding. We're not necessarily
I'm going to do this anyway.
Yeah.
It's going to take me some years to actually make a house out of it, but that's fine. But to give you an example, a piece of wood like a bit bigger than this black one I'm standing on. I'm not sure if you can actually see it. There's a corner here, and there's a corner beneath the beamer here. That will set you back about €7 if you buy enough of them, and enough is what you need for a house anyway. So the economy of scale compared to building something out of wood and then building a house out of wood is tremendous. And like I said, €30,000 for a small house should be doable. And I don't know, I know the English guys do some steel framing if they need to go across the living room and it's more than 6 meters wide. But even those things are not that expensive. So yeah. Any other questions?
Oh, we've got one at the back here. Actually, for time, I think probably you've got to wrap up after this.
Yeah.
Just in terms of the cost to the company who starts doing this, would that just be the CNC machine? Is it all quite standard, or would it require some specialist large-scale CNC machine?
No, I mean, you can use the CNC that fits inside a container. And that's what the guys who did this originally did. So
the CNC machines that they used are standard run-of-the-mill, not very special, not very accurate machines they buy. I think they spend about €30,000 on the container and the CNC machine and all the other crap that they think they need. And that's something you can just sell off at the end, or maybe borrow or rent or whatever. So that's an investment you need to make, which is obviously the same for a small and a big building. But if you want to make more buildings, that's fine with the same CNC machine. And I think you can build one yourself if you're into that kind of things. You can build a big enough CNC machine for about £5,000.
One last question.
About how long do you think the houses will last? Made from plywood doesn't sound the sturdiest and most long-lasting material.
That's
You can build these things in the rain, and then what you tend to do is you tend to render them externally, so it makes them more weatherproof. But
What do you render them with? Lime or something like that?
oh, pick a material. It's up to you. So
The English company, they're actually using standard, rendering for the outside. Same thing you'd put on a brick building or something. just to seal it. They've also done houses where they just put sheets of metal on, and it looks nice because it will give this rusty feel on the outside. As soon as the rain just kind of hits this barrier and there's a bit of dry air behind it, it's fine. The beauty is they've done all this work for us. They patented the whole thing, but it doesn't matter. It's source code. What are you going to do? And what they did is they asked insurance companies to see if it's safe, and they say, well, insurance costs are the same for a regular building. Life expectancy is at least 30 years, which is, well, it's not as much as a brick and mortar building may be, but in the end, if something starts rotting, you just take out the box and put a new one in. If that's, if worse comes to worse, you could always do that. All right. I think that's it.
Yep.
So if anyone else has any questions. So yeah, thank you very much. We had two talks at the price of one there. We had hacking healthcare and Amran's insight into how to take care of yourself, and all about new forms of construction.
Yes.
And I don't know why you're not putting it on Kickstarter. You get some money on that. Who would say no to a massive photo?
We want to keep control, and we want to keep control of how we would do it. If we had to do it on Kickstarter and raise funding, we give away control, and essentially, it might end up that the project isn't free anymore. And what's the point of doing this if a company holds it? It will just die.
Okay, I just want to build a house.
Very valuable. Okay,
Okay.
thank you very much.